Today we're talking about section, I had already mentioned 3.1 is all shortcut derivatives, right? But you have to manipulate a little bit on most of them, right? You have to manipulate on the shortcuts. So one of the things you'll have to do is like divide and conquer. So like if I say to you that f of x is x minus x squared all over x cubed, right? On this one you divide and conquer. So x minus x cubed, x over x cubed minus x squared over x cubed, right? Which what gives me 1 over x squared minus 1 over x, right? Which is x to the minus 2 minus x to the minus 1. So I manipulate, in everything in 3.1 I manipulate to become something clearly a power rule, right? And then I can take the derivative. So f prime of x here is negative 2 x to the minus 3, right? Bring down the power, reduce the power, plus x to the minus 2. So I get 1 over x squared minus 2 over x cubed. But then I want to put things back. So if I have multiple fractions, I want a single fraction, right? So I'm going to need x over x here. So my final answer for my derivative would be x minus 2 all over x cubed. So, but everything can be done with a shortcut in 3.1. I don't assign problems in 3.1, but you certainly can look at a bunch of them. Look at the examples, do the examples, right? But we've got our shortcut list, right? We know our shortcuts. We're going to put them all on our formula sheet for the exam, right? So we've got a good list of shortcuts. We're going to have more coming. All of the rest of the trigs is section 3.3. Then the inverse trigs is section 3.6. So all kinds of more shortcuts coming to us, okay? All right, but today our main feature is 3.2, the product and quotient rule. Now, notice I am teaching Chapter 3 into your time before your Chapter 2 test. Why? Because it's not difficult. The things I'm teaching are not difficult. I'm doing product rule, quotient rule, and trig derivatives. And then review. And then Chapter 2 test. And then when we come back from that, chain rule. The chain rule is the tough one. Okay. So this won't hurt you. This homework will help you. Okay. So product and quotient rule. So if I have a product of functions, I'm obviously going to use the product rule. So f of x times g of x. And if I have a quotient, if I have a fraction, I'm going to use the quotient rule, right? And for both of these, I use something I call a loop. Just so I can have the pattern memorized. Of course, you're going to have a formula sheet. You can put the book's version of it or your version of it on there. If you don't have a version, I'd say use my process. And then eventually we'd like to be able to do these without this little trick, this little loop I have. So what I do every time is I put my first function and then the derivative. And then I put my second function and then the derivative, right? So you can see f prime, g prime. And I do that for both of these. In fact, I do it for the chain rule too. And when I do the product rule, I've got what kind of looks like the letter P, right? And I can see that I get y prime is fg prime plus gf prime. So you can kind of see that I'm multiplying f and g prime and then adding the product gf prime, right? So there's my product rule. For my quotient rule, I'm doing it in reverse, and I kind of think that looks like a letter Q. I'm cheating a little bit. So I could see that y prime in the quotient rule is gf prime minus f g prime all over g squared. The g squared is not represented in that loop, but the numerator is, right? I'm going to prove the product rule today. But you'll see, I'll do this with every time I do it. For a while, I'll present it this way. And then by the end of chapter 3, you'll be doing these things without a loop, right? So, but you've got to practice a lot to get it kind of memorized. So there's my product rule. There's my quotient rule. I like to start these with things that are obvious, with functions that I don't need the product rule, and then show you I get the same result with the product rule. And then we'll move to something where you have to use the product rule, right? And we'll do the same with the quotient rule. I don't care if I get it all done today. If I have to finish the quotient rule on Friday, that's fine with me. So, can I start some examples? Anybody still writing here? Booty, do you know what's happening tomorrow? Friday? With the camera view? You're coming in with your camera view to show you taking the test, so I can see the computer, I can see you, I can see your papers, I can see your desk, okay, on your phone, right? Yeah. Anybody else miss Monday? Everyone else is here. All right, so let me do something that's obvious, right? So we want to do shortcut and product rule, and see if we get the same, right? See if we get the same result. So this is let's say y equals x squared, which of course is x times x, right? So obviously we don't need a product rule for x squared, but it is a product. And what do I get for my shortcut? I get y prime is 2x. Everybody with me there? Yes, we agree with that. Yes? Yep.
Yeah, that's fine.
So now with the product rule, my first function in the product is x. And what's the derivative of x? 1. Good. The second function in my product is x. The derivative again is 1. And I'm looking at this loop, right? So I get for y prime, I get x times 1 plus an x times 1, which is obviously 2x. Check. Easy, right? Let's do another one, shortcut and product rule. So let's say y equals x minus 2 times x plus 3. So clearly a product, right? Clearly a product. And if I FOIL everything out here, what do I get? I get x squared plus x minus 6, right? Agreed? X squared minus, plus x minus 6, yeah. And so what do we get for y prime? We get 2x plus 1. Everybody with me there?
Yes.
Nice. So now as a product, my first function is x minus 2. It's kind of boring. And my derivative is 1. Sorry. To make it so easy again. And then my product is going to come from x minus 2 plus x plus 3 obviously 2x plus 1. Check. Got it. Right. Let's do one that's not so obvious. And this will put some trig fear into you a little bit. So, oh, I'm sorry, is that okay? Anybody need me to go back?
Yes, I need you to go back.
Thank you. Sorry about that, Marcus. Okay. Let's do one that's not obvious, right? So I get y equals cos of 2x. Now, we're going to be talking about the chain rule here pretty soon, right? That first Monday after our test. But I can cheat a little bit right now. What's the interior function?
It's 2x.
2x. What's the derivative of 2x?
Should just be
2, right?
2.
So,
Yeah.
yep, y equals mx plus b. What's the outside function? What's the exterior function?
This.
Yeah, cos. And what's
It's gonna
the derivative of
negative
cos?
sign.
Negative sign. So when I get y prime, I'm going to get the derivative of the outside function evaluated at the inside function times the derivative of the inside function. This is the chain rule. Derivative of the outside function evaluated at the inside function times the derivative of the inside function. So I get minus 2 sine 2x. What is the formula for cos 2x? Who remembers the formula for cos 2x? It's cos squared x minus sine squared x.
Good one.
Cos squared x minus sine squared x. So this is on your formula sheet for sure for this first test. Right? Definitely for the second test. More likely needed for the second test. But I can see here I've got two products. I've got cos of x times cos of x minus sine of x times sine of x. So for each of those, I'm doing a loop, right? So my first loop is, first function is cos of x, derivative is negative sine of x. Is everybody okay here? Second, go ahead.
Can you go over it, please?
Markins, what?
Can you go over it again?
Yeah, so this is just an identity. This is an identity, right, from pre-cal. So there's nothing to go over. You got it memorized.
Oh, yeah, I got it. Okay,
Yeah.
I got it.
Yeah. So I see that I've got a product of cosines and then a product of sines. So I'm going to do two loops here to get this this derivative. My second function here, right, is again cos of x, and then the derivative is negative sine of x. I've got to do that same thing, right? I've got to do that same thing with sine of x and sine of x.
Why is the g cosine instead of sine?
So cos squared, yeah, I have a cos times a cos, right? So I'm doing this. Yeah, I'm doing this. I'm doing that whole loop there. I'm going to do another one for my sine times sine, right? So sine of x, and then f prime is cos of x. G again is sine of x. G prime is cos of x, right? And I've got, oops, sorry. I've got that loop there too. So my first loop, you can see, is giving me, right, minus cos sorry, minus sine of x cos of x. And then another minus sine of x cos of x. Right, so that's this part, right? That's the derivative of that part. Minus, right, minus my other loop, which is sine of x cos of x plus sine of x cos of x. Right, from this loop I'm getting that red piece. So it looks like I have 4 of them, don't I? All negative, right? So I have minus 4 sine x cos x. You agree with that? Minus sine x minus, right, minus sine cos, another minus sine cos, another minus sine cos. But I recognize here I've got another identity, right? 2 sine x cos x is sine 2x. I like Symbolab here. Let me do a Symbolab real quick. Symbolab.com, and then I've got all my functions pretty close here. I'm looking for ddx, right? ddx is my derivative. And what did I have? Cos 2x, right? So there they're doing the chain rule. But either way, you still see negative 2 sine 2x, right? Once we learn the chain rule, a lot of these derivatives will be quick. But we can't right now. We're not ready. So I'm trying to turn things into products or quotients. Go ahead, Noel. Anything?
Can you explain how you cancel out, how you simplify the cosines part of
Yeah. So this is an identity, right? So if you've got the physical book, right? So if you look at that blue page at the front of the book, on the second side is all those trig identities.
Oh yeah, not that one. I'm talking about the white inverse part. So where the green circle and stuff like that. So right part.
Yeah. So let me give line numbers. You tell me where you're at here.
So number 7 and 8.
Yeah, so 7 is my loop from here, right? Remember I had cos squared, so cos times cos, so it's a product. And then 8 is my loop from here, right? I have sine squared, so sine times sine, so a product. So I'm doing my little product loop for each piece. It gets messy, obviously, right? You got to stay organized. And there'll be several times when you look at the answer in the book and it's not the same answer you got. So the first thing is to look at your work, see if you see a mistake. You probably won't. Then try the problem again. If you get the same result you had the first time, then you know it's algebraic manipulation that you have to do. And you want to do it. You want to get to the answer the book has. And do another?
Sure.
One ready?
Okay, really with the one on 6, where you did your little loop symbol, it's kind of pointing at the left one, but you really mean it to be pointing at the right one.
The loop
right
is
one.
the letter P.
Okay.
So the green loop gives me that green derivative. The blue loop gives me the blue
Oh,
derivative.
Yeah, it's just it was just a little bit slightly confusing because you
Yep.
have the
Again, the loop is the letter
one on the
P.
inside that's green.
Yeah, but it's the letter
was
P
pointed.
for product rule.
Okay.
Okay, here we go. Y equals e to the x square root of x. So this is one we'll see. We'll see that I got to do a manipulation at the end. Right, so this is a pretty simple product rule. My first function is e to the x. The derivative is e to the x. Right, we got that memorized. My second function is square root of x, and that derivative I have memorized 1 over 2 square roots of x. That was on your homework you just turned in, right? So we're going to memorize it. Does anyone want to see the power rule there for g and g prime? Does anyone want to see the power rule there?
You can throw it up really quick.
Sure. If y is square root of x, that's x to the 1/2 power. Y prime is 1/2 times x to the 1/2 minus 1. That's 1/2 x to the minus 1/2. That's 1 over 2 times x to the 1/2. That's 1 over 2 square roots of x. Right, on your homework you did it with the limit, right?
Yeah.
Nice. So our derivative now, right? This is side work, right? If you don't want me to grade it, then you cross it out. Cross it out, I won't grade it, even if I see a mistake in there. So y prime is what? What's my product? Where's my loop here? With a plus in between, right? All right. E to the x over 2 square roots of x plus e to the x square root of x. And I look in the book and I see not only do I not have the answer, but I have 2 fractions and the book has 1 fraction. So our general rule is if I have fractions within fractions, simplify it, right? So it looks like I'm missing an LCD of 2 rad x. So I'm multiplying by 1 to the fraction that's missing the LCD, right? So what do I have now? Well, I have a single denominator of 2 rad x, right? And then I've got an e to the x plus 2x e to the x, right? I've got the 2, right? I've got the e to the square root of x times square root of x is x, and I've got the e to the x. I still look at the answer and it's still not right because I can see I can factor. I always want to have a single fraction completely factored, right? So I finally see it with an e to the x times 1 plus 2x all over 2 square roots of x. And there's my derivative. How we doing? We okay? Good. Let's do a tangent line. Let's do a tangent. Yeah.
For that last step, we took out e to the x.
Yes, factor. Yeah, I always want to factor as everything as completely as possible.
Okay.
We will, and the reason being is we want to find things called critical values of derivatives. So critical value is when the numerator is 0 or the denominator is 0. If the numerator is 0, we get a horizontal tangent line. If the denominator is 0, we get a vertical tangent line. So we're looking for these places in chapter 4, right? So I'll start talking about it pretty early. If I have things factored, it's easy to find zeros. If I don't have things factored, it's not so easy. So everything single fraction, completely factored.
I see how you factored it out.
Yeah.
Both,
and it's
both
always
the
easy.
plus terms have
Yeah,
e to
it's
x
always
in it.
easy for us to distribute back.
Yeah.
In fact, when you factor, you want to distribute
Yeah.
back to make sure.
But when I do it the opposite way around, it's obvious.
Yes, exactly. So let's do a tangent line at x equals 1. Right? So what do I need? I need a y value and I need a slope, right? So if x equals 1, then I know that y equals e to the 1 times square root of 1, which is just e. Right? So I have my x and my y value. And then my slope is going to come from y prime at 1, right? Which is e to the 1 times 1 plus 2 times 1 all over 2 square roots of 1. So it looks like 3e over 2. Everybody with me there? So my tangent line now is going to come from, right, y minus e equals 3e over 2 all times x minus 1. Make sure everybody's comfortable with that. I could put that directly into Desmos. I can't put it in my calculator, but I usually prefer y equals mx plus b. Sometimes the book will leave it like this. Sometimes the book will give you an mx plus b. For me, you can always give me an mx plus b. So I get 3e over 2 times x minus 3e over 2. I'm going to add e to both sides. And of course that is 2e over 2. So final answer, y equals 3e over 2 times x minus e over 2. And there's my tangent line. mx plus b, right? Yes, even though I could factor that. I like to keep it as, yes.
How do you find the y value?
Yeah, I just plugged it into the function, right? Once I told you x is 1, I'm just plugging it, right? Remember, my function is e to the x square root of x. So I just plugged into that, yeah. So to Desmos. Desmos. Desmos.com. Let's see, y equals e to the x square root of x. Next I had the point 1 comma e. And the tangent line of y equals 3e over 2 times x minus e over 2. Yes, I love it. And look at how steep that red line gets as it goes to 0, right? You see how steep? So you can see that at 0 there's a vertical tangent, right? Right at 0, looking at my slope, right? Where's my slope? Right, looking at my derivative at 0, you see I get a 0 downstairs, right? And that's going to give me that vertical tangent line. That's chapter 4 stuff already. But I can't wait. I gotta read the back of the book first. I can't wait for the whole book to find out what happens. So I'm cheating ahead a little bit. Pretty easy, right? It's not too bad. Just got to be organized. If you haven't done this before, I think the loop is helpful, but you don't have to do it that way. Let's prove this. and then we'll try some quotient rule. Okay. Now, when I do the proof, I'm not expecting you to repeat the proof. I'm just expecting you to agree, right? And I'm not a genius. I didn't come up with this proof. So I'm not expecting you to be able to come up with the proof. Okay. That's when you're going for your PhD in mathematics, is when you're coming up with your own proof on something. Okay. So for almost all of us, that's none of us. Thank God, right? But let's see if we can prove this, right? I want to prove that y equals f times g implies y prime is f g prime plus g f prime. Right, it's the product rule. And when I wrote that down, I'm looking at that loop. I'm doing f g prime plus g f prime, right? Well, guess what? Y prime is the limit as h goes to 0 of f of x plus h times g of x plus h minus f of x times g of x all over h. Right? Look familiar? This is our definition of a derivative using a limit, right? And so on your test, I'm going to say to you, for at least 2 questions, find me the derivative using a limit, right? I mean, just do every one that I put on every chapter 2 test, right? In fact, look at the midterms. There's one on the midterm at least, S2 as well. Well, I want to work on this inside function. Everybody okay here? Everyone know what's going on? Anybody staying awake? Udi, Markins, Mom,
Yes, I mean, I
Chris,
don't see
Abraham. Say again?
same number for y, I don't see any number like for
You talking about this page?
yes.
Yeah. So it's f times g, right? Y is f times g. I didn't put the x's in. I'm just a little lazy.
Okay.
It's f of x times g of x, right? So this is just, so I'm just asking to everyone agree that this is our definition of a limit, right? The original function evaluated at x plus h minus the original function at x, all divided by h, right? And we're going to do the limit as h goes to 0. So I'm going to manipulate this function a little bit, and this will be the first time you see me do this. I'm going to add 0. So I'm going to add 0. And the 0 I'm going to add is minus f of x times g of x plus h. So I'm going to add it and subtract it. Right, so I've added 0. Right, so do we agree that those blue factors cancel? Right, those blue terms cancel. Right, they're the same. One is positive, one is negative.
My question for
Yeah.
Yes, go ahead, Markins.
Why did you add 0?
Right now, right here, I just added 0 right here.
You add 0.
Yes.
Why did you put it?
Because somebody in the 18th century proved it. Probably Newton. I don't know who did it, but so, but you agree, all I need you to do, Markins here, and all of you, is to agree that I added nothing. I did nothing. They still have equality here, right? It's still equal to the original function of that limit that I was doing. So it looks like I've got some shared terms here. So I want to, and I put them in this order so that I could regroup. I'm going to divide and conquer again, right? I'm going to take my first 2 terms here over h, and then my second 2 terms over h. So I've got f of x plus h g of x plus h minus f of x times g of x plus h all over h, and then the second two terms, f of x times g of x plus h minus f of x g of x all over h. So divide and conquer. You'll hear me say that a couple times this semester, where I take a finished fraction and split it into pieces, right? And again, like Jesse G said before, it's easy to see it when you combine, when you go backward now. Not so easy to see it, right, when you factor or when you split a fraction up. But if you put them back together, it's obvious. Each of these can be factored, so I'm going to factor it before I go back to my limit. So it looks like I can take out a g of x plus h, and the rest of it you should recognize. And then the other one I could take out an f of x, and again the rest of it you should recognize. Right, you see what those two boxed pieces, those square bracket pieces are? They're, once I take the limit, they're derivatives, right? So I'm going to switch my order and then go back to my limit. So y prime is the limit as h goes to 0 of that second piece, that's f of x and g of x plus h minus g of x all over h, plus the limit as h goes to 0 of g of x plus h times f of x plus h minus f of x all over h. And of course, limit of a product is the product of the limits, so I could take the limit of each of the pieces, right? I'm really going to do this limit and this limit and this limit and this limit, right? And so the first one is clearly f of x times g prime of x, right? And the second one is g of x plus 0 times f prime of x, right? And so there it is. Y prime is f times g prime plus g times f prime. Check.
So I know that you said this before, but we're not required to like do that in the
Correct.
This is some of that stuff.
Yeah, what was that last part?
No.
It was just it was tear. Was it tear? You were crying through the last part of the statement. I couldn't understand. This is one of the reasons why I love mathematics, is because you can prove things. It's so rare that you're able to prove things, right? Prove that God exists. I was always trying to prove what came first, the chicken or the egg, or does God exist? And I don't want to get preachy or anything. But I like to say I swear to God I'm an atheist. But you get it? Joke?
Yeah.
How could you swear to God if you're an atheist?
It's an oxymoron.
Hey, what do you call me? Let's do a couple quotient rule and then quit for the day. Okay?
But let me.
Yep. I can wait.
Get the rest of that down.
Yep.
I do want to get it down, not just MS Paint it.
Yep. Gotcha.
Because I like to have these kind of stuff.
And this is something like Noel, I would get Schaum's outline for calculus, advanced calculus. All the proofs of everything are in that book. It's nice. There are proofs in the back of our book. I think the product rule is in there. So like Noel, I would say Noel's a math major and Noah's a theoretical physicist. So both of you might want to try and prove the quotient rule. It's very similar. rest of us can do nothing, go to lunch or something. Yeah, there's a fine line between, and I remember having this, wanting to get done with my degree, right? I wanted, and there was time, and I advise now, so there's a lot of time where students are going, I really want to finish by this time, right? But things happen, so you have to be willing to be flexible on that, right? Like I said, Calc 2 in the summer is fine if you're really only doing that. But for me, it took me 3.5 years to get through my community college. My 2-year degree took me 3.5 years, including summers. Because I started in 8th grade math, basically. And then I changed my major. It was computer science, and then I switched to math only, against all of the advice of my professors.
So what, you came out of high school knowing 8th grade math, basically?
I came out of high school with a less brain cells.
Okay, yeah. Some of us, that's definitely was the case for us.
Yeah, I did nothing in high school and still passed. I don't know how, but who cares? When I taught high school, they told me I couldn't fail anybody. So let's do some quotient rule. Here we go.
So you became a college professor. So you
Well, this is many years later. When I graduated high school, I tried community college, hated it. 7 years later, still broke. Went back, hated it, but I gave in. 3.5 years later now, I graduated from community college, went to Rutgers in Jersey. That's where I grew up in New Jersey, and finished my degree in 2 years. Then I taught high school for 14 years. And then I went back to school for my master's to try and work. Oh, Montclair, Tally's from Montclair. I'm from Red Bank. You don't always figure things out right away. I remember I used to want to be a garbage man growing up because I wanted to hang off the side of the back of a truck going down the street. Didn't realize how much that job stinks. All right, let's do some quotient rule. Let's start with something obvious and then see what happens with the quotient rule, right? So let's start with y equals 1 over x. It's a quotient, right? It's a quotient, yeah? But this one we can do with a shortcut, right? We can do a power rule here. So what do I get for y prime? I get negative 1 times x to the negative 2. Oops, sorry, y prime. So y prime is negative 1 over x squared, right? So I want to see if my quotient rule will give me the same result. And remember, we're kind of learning these things in order. If the shortcut works, use the shortcut. If you need the quotient rule, use the quotient rule. If you need a chain rule, use the chain rule. So try the easiest. We're learning them kind of from easy to difficult, okay? So if you can take the quickest way, take the quickest way, right? But we're just trying to verify that the quotient rule works here. So my first function, my numerator is 1. The derivative of that is 0, right? The downstairs function is x, and the derivative of that is 1. I also need the downstairs squared, okay, which is x squared. And you go, well, why? Well, you're going to prove it the same way I proved the product rule, right? So most of us can just accept. We don't need to know how a car works, an engine works to drive. We will drive better and save gas if we understand it, but let's just go. Let's just go, right? So quotient rule, right? I need the negative. I need 0 times x minus 1 times 1 all over x squared. Done. Easy, right? Negative 1 over x squared.
I got a question.
Yes, Markins.
How did you get x squared first?
One more time. How did I get what?
X squared, did you get it?
Downstairs squared. That's part of the formula.
Oh, it's like an extra step.
Yeah. And again, where is it coming from? Do the proof. If you really, you know, are just in complete disagreement, do the proof.
And the term f prime 0. Where
Yeah.
did you grab the 0 from?
The derivative of 1. So my upstairs function is 1. Derivative of 1 is 0.
Oh, okay.
Right? Derivative of a constant is 0.
Yeah.
Yeah.
There's no x.
Exactly. Let's do another. Markins, we okay?
Yes, I'm okay, thank you.
Yes. You know, and my chat is open too. If you need anything, if you need me to slow down, if you need anything like that. Let's do another one. Let's see. Y equals e to the x over square root of x. So this is one of these ones where I'm going to have extra. I'm going to have more than one fraction. Okay. In fact, most of the time you'll have to manipulate, and it's kind of horrible. It's hell a little bit. How much we're going to have to do the algebra in this from now on in this course. There's going to be tons and tons of algebra. That's just annoying, but there's no way around it. So here we go. Upstairs function is e to the x. Derivative e to the x. Oh, I like that one. Downstairs function is square root of x. Derivative, hopefully memorized, it's 1 over 2 square roots of x. And then I need to take that loop and divide by the downstairs squared, right? Which is square root of x squared, or just x. How are we doing here? Abraham, Udi, Chris, Maab, Markins, your cameras, please. Go ahead, Markins.
For this one, when we just take the radical, then we put it to Pareto.
One more time, Markins.
Yeah, for this one, I say like you take the square root of x and you put it to Pareto.
Yes, exactly. Always the denominator squared. Yeah.
So we don't have to take the 2, just leave it like that. What about the 2?
G squared. Square root. No, the original denominator. The original denominator.
Oh, okay.
Yeah.
Okay, I see.
Original denominator. Yeah.
I get it. Thank you.
Yep. Is everybody else here? The people with the cameras off, are you here? Or are you asleep?
I'm struggling, but I'm here.
Chris, you're struggling? Get some tooth.
I'll get it. I'll get it sometime.
Okay. Abraham, you here? Gerber,
Yeah,
you
I'm
here? Markins is here. Thank you.
Yes, I'm able to start.
I know you are. Gerber, you here? Gerber? This is why I want the cameras on, right? If we were in a class and you were asleep, I'd throw an eraser at you. That's what I learned in high school, teaching high school. How to throw soft things. Okay, so derivative, right? What are we going to get from our derivative here? Y prime is e to the x square root of x, right? I'm doing this product here, right? Yes? Minus, yes? E to the x over 2 square roots of x, all divided by x. How we doing there? Fractions within fractions, right? So, and this one I want to clear fractions. I'm not going to do an LCD thing, waste of time, right? I mean, I'm not going to do an LCD upstairs and then keep, change, flip, and all of that. I'm just going to go right to 2 rad x over itself, right? So it looks like I get 2x e to the x, right? I'm distributing that here. And then my next one, it cancels, right? The 2 rad x cancel. And then downstairs, I have 2x rad x. Make sure everybody's okay there. Still not done. You can factor out an e to the x. And done.